Hello everybody, this is your third favorite systems design YouTuber, Jordan, back at it with another video, still hungover at 4 p.m. on a Saturday, so hoping to get through this one kind of quickly. Anyways, today's we'll be talking about search indexes, which is yet another niche type of data store, so let's go ahead and get into it. We're looking at the tail end of the systems design concept videos now, so let's plow through these and then we can get to some questions. Alrighty, so at this point we've spoken about quite a few different types of problems. But today we are going to address a different one, which is searching, specifically probably text searching. So as you can see right here, I've got my beautifully artistically drawn search bar. Think of us as on Amazon, and I am searching for tissues, as I often am because I'm frequently running out of them. So we might get a few options back, and as you can see, the word tissues just has to be contained really in any of the text for that listing. So in this case, highlight that guy there. As you can see, it doesn't necessarily just have to be at the start of the term. So, databases don't really handle this problem very well. Why? Well, our first instinct might be to make an index, or a secondary index perhaps, on this text field that we're searching for. So let's say we wanted to search the term apple, and so we put an index on our actual text field right here, as you can see. And so that would mean we were sorting them by the first character of the text, and so on. But in this case, even though apple starts with A, so you would think that it would be at the top of our index, as you can see, we've got this listing right here which contains the word apple, and it is at the bottom of our index. The reason being that when doing a search for text, that text could be a substring at any single part of the term, and as a result of that, a traditional index isn't going to work for us here. We have to do something a little bit more intelligent than that. So databases are not going to solve our problem. We need to use a different type of technology and or data structure. So, what are we actually going to go ahead and do? Well, we're going to use something known as a search index. And so search indexes are actually capable of solving our problem in a much better way. The reason for this is they take a typical document, something that we might see in a database where we've got something like an ID and a piece of text that we want to be able to search later down the line, and it does something called tokenizing, where tokenizing, is basically scrubbing down the text in a way such that it makes it easier to search down the line. For example, if we have the Apple computer symbol right there with some sort of like trademark logo, we don't care about that. We want to make this lowercase. We want to make this a lowercase c. We don't really care about our space. And so then we end up getting two different tokens, Apple and computer. And in what we eventually create, we're going to basically have the actual token right here, and then all of the document IDs. So this is going to be a list of document IDs that correspond to it, or that contain that token. And so what this is known as is called the inverted index. And our search index is effectively an inverted index, or sometimes possibly even multiple inverted indexes, so we can do multiple interesting, cool types of searching. So the example of the inverted index that we just made is going to help us do something called prefix searching, where basically, it's very easy for us to search for terms based on the prefix of those terms. So here's an example. Here's our inverted index right here. Hold on, let me be able to draw that. So we've got our inverted index. And let's say we want to search for all of the documents that have words starting with the letter C. Well, the nice thing that we do in our inverted index and a search index is we actually keep it sorted. So as you can see, we've got A first, then B, then C, then another word with C but is lexicographically later. And so what we can do now is we can actually binary search as we would with a typical index. And so we would say, is this less than C? Is this greater than C? Oh, this is less than C, so let's look down here, blah, blah, blah. Here are our C terms. And so now we know all of the documents where we have terms with cantaloupe and cherry, which both start with C, which is really, really nice. So prefix sorting, like I mentioned, super easy with an inverted index because we're doing all of this work up front to tell us where all of the documents are that contain the terms that we're interested in. Another cool thing that we can do is suffix searching. So I gotta make this a little bit bigger because I'm bad at making my slides a consistent size. So let's imagine we've got this guy over here, which is like our prefix inverted index. What we can do is whenever we take in a new document, we can actually keep a second copy of the inverted index specifically for searching words by their suffix. So as you can see, we've got apple over here, but what we'll do is we'll actually reverse that word. So A-P-P-L-E becomes E-L-P-P-A, and we'll put it in our basically suffix inverted index. And note that even though the order of the words here is apple, blackberry, blueberry, raspberry, in our suffix inverted index, we're still ordering our terms alphabetically. So it's actually apple, then I believe it is blueberry, then it's blackberry, then it's raspberry. So note that this is still ordered by suffix. And why does this help us? Because again, let's say we wanted to search for all of our fruit that end in the word berry. This is super easy. Berry, all we have to do is reverse it. We know that reversing berry turns into YRREB. And then we can binary search our index for all of the terms that start with YRREB, which is this guy right here. And so this allows us to really search for terms that end with a certain suffix. So we get 92, 43, 19, and then we could join those on our SQL database, or we could even keep the entire record in our index itself if we want to lower our latency at the cost of storing more data. Okay, so now that we've gone over the general premise of a search index and some of the things we could do with it for both prefix and suffix searching, let's talk about Apache Lucian. So Lucene is a very popular open source search index, which is effectively just built on top of an LSM tree architecture. However, the really nice thing about it is that in addition to things like prefix search and suffix search, which are super basic, it supports a bunch of other complex types of searching, where you can do like Levenstein distance, find words that are close to the word that you typed in, coordinate searching, time searching, anything like that. And so as a result, it's got all of these really rich features that make search indexes super useful in order to greatly speed up those general searchings as opposed to searching specifically by an indexed value. And so Lucene is something, or rather it's just a piece of technology that is going to be super useful whenever you're trying to build a search index. Of course, Lucene is one of those pieces of technology that typically is meant to be used on a single node. So in our next video, we're going to be talking about how we might distribute something like Apache Lucian, make a distributed search index, and make it run efficiently. Anyways, guys, I will see you for that one. Have a great rest of your day.